Bloody hell, what is going on here? Morning everyone, you can probably tell by the title what we're doing today. We're fitting this new 18th edition compliant SPD Hagar consumer unit. I bought a few bits, so we'll go through them as well today. Just trying to hide the McDonald's wrapper. But let's over to the job and we'll have a look. So I nipped into Toolstation, just came out to get some bits and to get some of this for sealing up fuse boards. Obviously because we should be sealing them up. We're making holes in 18th edition boards that are fire sealed. We should be sealing them up. I asked for 5 of these. I did the order online and they put 5 £6 brushed chrome switches in. Am I too honest? I gave them back. I said, look, I don't need them. He said, oh mate, I'm the manager, thanks for that. I've just taken over and this is like the 4th time this has happened. They're not even like looking what they're putting in the boxes, so I could have got away with sort of 30 quid's worth of switches, but I'm a bit too honest for that. So I've got everything now. We'll head over to the job and then we'll run through and I'll show you what we're doing. Right, so here we go. We've got an old Hagar board, 1361 fuses. We've got an RCD protecting 2 circuits here. There's one ring final circuit, 2 lighting circuits, smoke alarms, a cooker and heating, which is, it was a tank, it's now got a boiler, so that does the boiler. Okay, the reason we're changing this is now at full capacity. So I'm putting a 10-way Hagar board in because they are going to want to do some extension work at some point, so we're upgrading the fuse board, and we all know that these are not great, are they? 3 amp. It's actually got a top fuse in there, which I don't think is the correct fuse for these. It should be the bigger. No, they've all got them. That's what we got in there. 5. That's the one. That's the bigger ones. 1361. So if anyone wants this, John Ward, Big Clive, if anyone wants this board, give me a shout and I'll send this to you, and you can have this and put it in your collection of electrical goodies. So I've incorporated this with again, put the onus back onto the client. Just say, look, I'm going to do a full test before, and then obviously when you do the testing you get your readings. Then if they're good, they're good. Any problems you tell the client before you repair anything, because it's back on them and there's extra charges for that, so don't forget that. And also I recently did my 18th, which we passed. Andy came, did his, he passed as well. So me and Andy are still, you know, people worry that we're not, you know, together. We're still friends, we're just doing other jobs, it doesn't matter. So he passed, I passed, and so there's a lot of things that I did the 3-day course. It was really, really good, JTL. And the guy, Graham, he was fantastic. So there's a lot of things that he's put in my head which we should be doing, which a lot of us don't do. So I'll probably run through those today. It's just good practice, and you know, why aren't we doing it and stuff like that. So yeah, a lot of stuff is recommended, but we should just be going above and beyond really of what we're meant to do. So we'll run through that today, but we'll get on with this, and I'll get into this, and then I'll tell you as I go what we find. Right, so first thing I noticed, the tails are only 16mm, so I'm hoping there's a 60 amp fuse on that. Obviously it's sealed, so what do you do, guys? You cut the seal. I was told in my 18th edition that we definitely can cut seal, and we definitely can pull the main fuse. I'll show you out in the cupboard now. Okay, so we've already got a switch here. Fuse is sealed, but I do need to check this, so I'll either ring up the DNO, get the information on, cut that seal and reseal it. It's up to you what you want to do. But yeah, that's already got it, and you can see there, just coming out the bottom there, we've got a PME earthing system. First thing I just want to talk about, when doing end-to-ends on your ring main, don't worry, the board is off, it's out there, it's locked off. When doing your end-to-ends on the ring main, on the ring final circuit, obviously we're checking continuity, and we get a resistance reading between live, neutral and earth, CPC if you like, But when you come to a radial circuit and you're doing your R1, R2 readings, how many of you actually go between the neutral and earth and the live and earth? Who does that? Because we should be doing that. We should be, you know, we just assume, yeah, great, we've got live and CPC. We've got that. We've got a good reading. That's our R1, R2. But why aren't we checking the neutral and the earth as well to give us that reading, just to check that we've got, because, you know, what does burn out? The neutral. So we've got to check we've got no bad loose connections on the neutral too. So that's one thing that probably some of you have been doing, but, you know, I'm not going to lie, I've not been doing it. So I've just been doing as per the sheets. You just do your one test and it's good enough. So I'm going to now be doing my neutrals as well on the radial circuits and stuff. That's the first thing that the guy told us about. Well, this isn't a testing video. I'm just going to run through a couple of bits what I'm doing. So I've put my there's only one ring final circuit in this place. So I've done my figure of 8 there with the wagos. Just put the opposite live and CPC with each other, and then literally run around with your tester. I'm just using my Q-Tech with this little Martindale attachment, and then you can just plug straight in. And then you're looking for readings to be very similar. Okay, 0.55, you're looking for something similar on each socket. Obviously look at that, yeah, 0.38, so that tells me that this socket never gets used. So if I give this a good little clean up, I should be able to get that reading roughly the same. We'll get, see, look, 0.47, we'll get that even lower. So you're looking at these sockets to be similar around the ring final circuit. Obviously, if they're not, then you know it could be a radial if the reading's higher. So I'm just going to go around now and do that. Okay, now so my anything that I don't like, it's not going to be a moan as I used to do. It's going to be an observation, and I'm going to tell you why I didn't like it. So all these conductors have not been doubled up, and they're all very, very loose in these terminals. So what you should have done was double these over. So just bend these over. It gives it more surface area for the terminal screw to bite on. That's my observation. So here we go, this is the boiler, this is the point I'm referring to. So what I'm going to do is just test between these two to give myself a reading, and then I'm going to switch it over and do this neutral. I'll let you know what I've got. Okay, so on the CPC and the live I've got 0.08, and I've just switched them over. So on the CPC and the neutral, 0.08, so it's bang on. It's a very small circuit, literally drops down and goes to the fuse board. Wired in 2.5, so per meter you get resistance reading. I'm not going to tell you off by heart. I did learn it in the course, but it's in my book. So yeah, so that's fine. Now, as I'll leave that like that, because I can come here, I can do an earth loop reading. I can go in insulation, resistance test this now. Yeah, and then I can do my reading. I can screw that back. That's a little bit later on today. It's a bit of a fire hazard, isn't it, waiting to happen. So, observation again. It's not been put in the terminal screw correctly, and the insulation's been stripped back too far for my liking. So I will repair this now. Easy little repair there. I'm going to just do the same with these because they're a little bit long. Look. Actually put that down, look, they're a little bit long, so I'll shorten these ones up, get them nice and tight, look, because you can see the terminal moving, but just a little bit long, so I'll just do this while I'm here. All right, just a little tip, a lot of you guys probably already know this, I have taken them out, don't worry, but look, it's silicone, so don't just go rah and rip that off the wall, because you'll rip all this with it. Just get your knife and just go slowly. I'm not going to do this one-handed because I will slip, so just do this gently around the whole switch, and then that will come off as clean as anything. It's interesting, this has actually got the twin and earth with the, this is for the lighting, so you've got the two reds, look. So you have the feed, and then you'll have the common, and then the switch line going out in the red, so you don't need to flag it because it's already red. Obviously it's a brown now, but back in the day it was red. I've actually got to change this dimmer actually, so that's the reason I've taken this switch off. I've got to change this dimmer because they have, this dimmer doesn't like these lamps, so I've got to change these lamps to LEDs, and I've got an LED dimmer, and I've got some LED lamps to put in these. I think they're just small SES. It's going to be a lot more efficient for them, because these are halogens, and these are 28 watt each, and look, as you can see that one's already blown. So they're going to be saving a lot of power. Something a little bit strange going on with this downstairs lighting. I'm getting 135 ohms between the live and the CPC, and I've just switched it over and gone between the neutral and the CPC, and I'm getting 0.55 on the downstairs lighting. So I'm going to have to go around and just check a few things now to see why that reading is so high. So there's a couple of little weird things going on with this lighting. I don't know what this smoke circuit is. I'm getting some sort of reading through it. I'm going to have to be a little bit careful. I'm going to do some insulation resistance tests between these now. But I found why that reading was so high. Look, I've just found that was sort of biting on that rather than the copper, and that's how much was showing. Look. So I've now retested. It's a little bit bizarre. It was sort of reading through here. I'm not entirely sure why that was high, but I've now found it. I need to check that they've not wired this as two circuits and it's interconnected somewhere. So I'm going to do some insulation resistance tests in a minute between these. I'm going to rip this board off now. It's free to come off now. And this brings me on to the second thing that we do. Well, we just tick that box, don't we? Gas and water, we just tick it. I've now bought a new fly lead, so I'm going to be disconnecting these. This is off, so there's no potential for fault. And I'm going to be checking the actual resistance of these two bonds and how good they are. That's another thing the guy said we should be doing. I know in a lot of new installs we put this cable in and we just assume it's good, but we should be checking it. So that's another thing really. Well, I'm just moving on to this cooker switch. I just want to check the continuity of the CPC here. As we can see now, that is already within the zone. It should be 100 mil minimum. It's not damaged at all. You can see there's no melting or anything, but it will go down as a bit of a breach. And if you look at your code breaker book, you'll see that's in there. Okay, straight away I can see this is going to be a complete ball ache to test. It's so tight, and I've just pulled that out. Look, and look what's already fallen out. The CPC's there already fallen out. Look, 1 and 2. Yeah. That would have been a nice high resistance joint there. What a bloody nightmare that was. Well, I've got them in there now. I've just checked my R1, R2, and I've just done my neutral as well. Both perfectly good readings, both exactly the same. So I'll now leave this off and I can do my live testing here. Turn that off to do the insulation resistance. Well, I got here at 8 o'clock this morning. I've just checked the time on my imaginary watch. It's now 10:30, so that's taken me 2.5 hours to do this little tiny board with 5 or 6 circuits in it. So it's quite thorough. It's quite a thorough inspection, if you like, on the initial testing. I'm now going to set you up on the laps, get this board changed, get it in, and then we'll have a look. It would so annoy me if that's my house. Look, no extra charge to the client. Job done. Right, quick next little thing we're moving on to that we spoke to on our 18th edition course. The chap said, I guarantee a lot of you are working to the 17th, and there was probably 10 or 12 of us in the room, and we all said, no, we're all 18th edition, blah, blah, blah. And he said to me, not to me, he said to us, can everyone put their hands up who's fitted an SPD? And there was me, Andy, and another chap. And he said, well, there you go then. So he said, why aren't you fitting them? And I said, well, I don't know really. So here we go, we're fitting the Hagar. This is my go-to brand now, this is it now. This is what I fit. And with the SPD built in, okay? So we've got the SPD, the main switch, and then the split load RCDs, which will protect the circuitry, and it will give them a nice 4 or 5 spare ways in here now for their extension work they want to do. So we'll get this out and we'll get it boshed on the wall. Going back to this, if you're not fitting boards now with SPDs, why not? And also, if you're not fitting these, you should be getting an email or a letter from the client, which you then attach to your test sheet to say they didn't feel the need for an SPD, because it will come back onto you if anything goes wrong now. If your name's on this board and there's a transient over voltage comes down the line, blows up any of their stuff,
they say, well, why didn't the electrician fit an SPD at the board? It could have potentially saved your stuff. And they'll say, well, I don't know, he didn't offer it. So you should be offering it, and if they don't want it, get a reason why. And just another thing to point out, the RCDs in here now are type A. They've gone from AC to type A now, which is good. So to anyone watching this that isn't savvy in these are one-hit wonder. So if you have a big high voltage comes down the line, it will spike here. This will take up the percent. There's a percentage. This will take up the percentage of the spike, and obviously green is good. And if that goes red, it means you've had a strike. And this now needs to go in the bin. But you can buy them as a cartridge. That goes in the bin, and you just replace these then. It's as easy as that. And I believe, don't quote me on that, which actually it won't. Yeah, you will have to. Yeah, so you will have to get an electrician to do it, to take the cover off and to get these removed and replaced. Right, I'll just stop you there on the laps, show you where we're at, board's off. Look at this for a fire hazard. So back in the old days, this was fine. We want that fire that starts in this consumer unit to then go up this wall, burn all this timber above here, and then get in the upstairs. That's what we want. Not. So what we're going to do is, when we put our new board on, we are going to seal, I'll show you, but we're going to seal this, because if there is a fire in this board, we want it to go out. So the intromittence mastic will expand, and then it will just literally give this fire nowhere to go. And the board being metal, it should contain it and not just melt and just then spread. That's the theory behind all this. Okay, I'm just using these pump fixings, going straight through the plasterboard. It's a better fixing than those little wiggly worms, so just these little pump fixings there. About these Hagar boards, we spend all this money on these. This is nearly £200, and look, they give you that 19p piece of grommet strip there, which just keeps coming off. It's crap. That is completely crap. Give us a bloody seal that goes on there. You can make that easy. Doesn't need to be a bit of grommet strip. That's a little bit lazy if you ask me. So now I'm just going to dress all these in, get the mains tails back in. I've checked the fuses are 60 amps, so I can use these 16mm tails. That's absolutely fine. Yeah, sweet as. Well, I'm going to now, if you see the bubble, yep. So I'm going to now crack on with this. What I'll do is I'll just go around using my standard screwdriver, just do them all loosely, and then I'll get the torque screwdriver out of the van and I'll torque all these down to manufacturer's spec. That's another thing that the guy said in college. If you've doing fuse boards and stuff, why the hell are you not using torque screwdrivers? Because if one of these comes loose, you go to court and they'll say, can you show me your screwdriver please that you used? And if you pull this out, you're bang to rights. Okay, so you should be using a torque screwdriver on these terminals, definitely in the fuse board, not like a rewire, etc. You will come across this. This is the only one I've had to extend, but I've put it in plain sight. Comes out, extends there, and drops down to the 16 amp. That's just doing the boiler, so it's like a 3 amp circuit. It's doing the boiler. That's all they've got is a combi boiler. That's it, you know. Everything else, this has got to be tidied up a little bit, but this is that weird smoke circuit which I've left out, and I've just got to put this lighting circuit into here. So I've got up and down split, I've got ring main, cooker, and then I've got immersion and lights, and then all these are spare ways for them to do what they want. Right, consumer unit's pretty much there now. What I'm going to do now is seal this up. I see a lot of people using the fire foam. It's not very easy to control, whereas this stuff is literally just you can just, you know, put it where you want and control how much you want to come out. So yeah, this stuff This is what I use all the time, really. Not to be mistaken for painter's mate. There you go. Well, there's that old smoke alarm circuit. It's just linked out there. It doesn't go anywhere. I can't find it. It must be in a joint under the floor. So that's just linked out, and I'll put a label on that old smoke alarm circuit. Question mark. Get away with taking this oven out, but it seems I've tested to there. It seems like there's an earth fault from here to this oven. It's an earth to neutral fault, so I've got to take this out now and prove my wiring to the connection unit, and if it's good to there, then the oven's kaput. Okay, so I thought I found it. The whole weight of this oven was sat on this flexible cable here. If you can see there, that's enough to cause a neutral earth fault. It's on a plug top, which is strange. I can see why, because they've powering the igniter for the gas off of it, and it's still tripping, so I've got to take that off. So absolutely fantastic. We've got a dead short between this neutral here and that earth there. Literally goes from here on tiles, down here, down here, down here to here. It's got a neutral earth fault. So somewhere someone has put a nail or screw through this cable. I find it hard to believe, because look, there's no plaster marks anywhere, there's no hole marks, and there's not even a worktop batten. That's just the worktop, and that's it. So somewhere there's damage to that cable. Well, I've just dug that out. It's dot and dab, and it's capped. Look, the cable is capped, so I can only assume they've put a nail in the wrong place. That's all I can assume really on this one. To tell the old client about this one. I'm just going around the board now and checking the torques and everything. There you go. Lovely. There you get the idea. These are higher than these. I think these are 1.5 and these are 2.8. But check the manufacturer's recommendations. Stickers on there now. I don't know why I'm covering the number, because you can find me online anyway, but I've put that on twice, don't know why. Oh well, that's theirs, that's ours. And Eagle Eye viewers, this has changed to 6 monthly. That will be an 18th edition question there for you. There you go. There you go. I've had to leave the oven off for now because I haven't spoke to the client yet about that. Just going to label this up now, SPD, and also put on here, this board has been sealed with intramittent mastic. You know, any modification must be retainer fire to comply with 18th edition. I didn't forget, look. SPD, surge protection fitted. A little side job today, fitted this new brushed dimmer and some compatible LED lamps, look. Nice. There we go. Right, I've spoken to the client, a quick fix regarding this oven. That igniter never worked anyway, so that plug's going. I'm going to cut that socket out, change that for a single socket, and then I'm going to drill that up through the worktop over here out the way for now, and then it will literally plug into that socket and literally do the oven. That's going to be the quick fix for the oven today. Here we go. It's 100% temporary. It is a heatproof flex. I'll advise them not to use that back ring for now. This kitchen is getting ripped out and replaced. So this is just a temporary fix. This is what he wanted me to do. Right guys, that's me done on this one. Everything's clean and tidy. Perfect. Yeah, I'm happy today. It's gone, wow. That was the only thing that I found which was damaged, was that cable in the wall. That's a temporary fix for that. This is where the fuse board lives. In here, I think we need to get a few more labels on these boards. What do you reckon? So if you found it interesting, give me a thumbs up. And I'll apologise for no video last week. I've been so busy, but we're going to keep on it from now on. Take care. Bye bye.